Hi everyone, welcome to Python Basics series. In this session, we will learn about Python exception handling, the try and except block. We'll talk about what Python exceptions are and why they occur. We'll discuss how to use the try and except blocks to handle errors gracefully, and also discuss using the else and finally clauses in exception handling. We'll wrap up with some real-world example to illustrate proper usage of the try except blocks. So exceptions are errors that occur during the execution of your program. They can disrupt the normal flow of a program if not handled properly. Python provides the try and except blocks to catch and manage these errors, allowing your program to continue running or fail gracefully. So the basic syntax of a try except block is we have a try block. The try block contains code that might raise an error, which is a risk operation, and the except block contains code that runs if a specified error occurs, which is the exception handling block. Right. So I will do an example for handling division by zero. A common error in Python is dividing by a zero. Here is how you can handle it. So here I will create a try block. I will declare the variable numerator, which I will assign a 10. I will declare a denominator, which I will assign a 0. I will declare a result, which is in the numerator divided by the denominator. And then I will print the result. Right. Then afterwards, I will handle my exception here. In case there is a zero division error in our try block, so except for zero division error, so here we print error can't divide by 0. So I'll run this code and we'll see the result. Right. So here's the outcome. Error can't divide by 0. Right. So we'll move on to an example where we are catching multiple exceptions. So you can handle different types of exceptions by specifying multiple except blocks. So here is an example. I will declare a try block. I'll write a try block here. We have a variable value which I will try to cast a string to an integer. Right. So of course here this will raise a value error. This one we can't cast a string to an integer. Right. So here I will accept with a zero division error. I'm just trying to demonstrate some catching multiple exceptions from a try block. So here I'll put a zero division error. I'll catch a zero division error and we print a zero division error. Right. Then here I will accept for a value error, since that one is obviously going to raise a value error. And then we print a value error. So I will run this code and we see the outcome. As you can see here, we got a value error. So which means this block with the zero division error, since it wasn't a zero division error, so it didn't use this block to handle our error. But there is a value error here which was caught, and we see this outcome here. Right. So alternatively, you can catch multiple exceptions in a single clause. So I'll do an example here. Right. So like in this case, we can accept, then we catch zero division error and the value error in one block. So here we print an error occurred. Let me see. Let us store the value of the error in a variable e. Right. So here we accept zero division error and value error is e, and then we'll print the error. Right. Let us an error occurred. Right, this way. And when we run this code, we'll find here an error occurred, invalid literal for int with the base 10 ABC. So it caught the value error. Here, let us let us change this variable and put a result, which is equal to a 10 divided by a 0, and we run the code and see the output. So here we get a different error, division by 0. So this is how you can catch multiple exceptions in a single except clause. Right. We'll move on to using else and finally clauses. The else clause runs only if no exceptions were raised in the try block. So just like that, here we have an example. A result is equal to 10 divided by a 2. Right. So here we accept for a zero division error, and here we print zero division error. Then we put an except block. All right. The except block, in the except block, we will print result is result like this. So I'll run this code and we will see the output. Oh, sorry. Yeah, I was supposed to put an else, not an except. Right. So here we get our output, which is a 5. So the except clause runs only if no exceptions were raised in the try block. Right. So this is how the else works in a try except block. Right. I'll move on to using the finally clause. The finally clause always executes regardless of whether an exception occurred or not. It's useful for cleaning up resources like closing files, right? So here I would create a try block here. It's a file now. we'll do file handling in our next session. So here I'll just do some example, right, which includes some file handling, right. So file is supposed to open example dot text dot txt, right. Right, in a read mode. So here we have content is equal to file dot read. All right. So here I'm trying to open a file which does not exist in my root directory. So here I have the except print file not found, right, and then we have the finally. Let me put an else, right, else we print the file content. So we'll try opening a file. We try opening a file, and if a file not found, the error occurs, we handle it in this section. Else we print the content, the file content here. File content, right. So here I'll put my finally, which will execute no matter the what happened in the try or except block, right. So here I'll put in file to close the file, right. This will execute whether or not an exception occurred, right. And we print a file closed like this. So I'll run this code and we see the outcome, right. So here right, so after running this code, we get the error file is not defined here at this line number 9, where we attempted to close the file. So this issue arises because the file variable is only defined within the try block, and if a file not found error occurs, the file variable is never created. So to fix this, we may use we may define it outside the block of the try. We may define it as file is equal to none maybe, but in this case, let's say we create the file here, a new file. I'll put example.txt like this, and we try to run this code. You can see that the file is closed because there was no file not found here. So that is what happens. That is what happens here. So we'll move on to some real-world example. We'll try using try except block and showing the right methods of doing it. So here, a common scenario is prompting the user for input and handling invalid input gracefully, right. So here I'll type in what I'll use a while loop, right, while true, right. We try we have a variable age from which we will get the input from the user, enter your age. Right. So if age is less than a 0, we raise a value error. We raise a value error, which will override here, and we say age cannot be negative, right? And we'll put a break to exit the loop if everything is fine. Right here, I'll put a break statement to exit the loop if everything is fine, if age is not negative. And then I'll put an except block here for a value error, which I'll put in the variable e, right? And we print invalid input, right? And I'll put in the error which we got from the value exception from here. So here we'll print your age. Your age is age, like this, and I'll run this code. Right, I'll try putting a -1, and you see that it looks it raises a value age cannot be negative error, and I am prompted to re-enter my age. Let me try to put a proper age here, and it tells me your age is 67. So this code works like this. The try block attempts to convert the user input into an integer. All right. If the input is not a valid integer, if the integer is negative, a value error is raised. Right. The except block catches the error and prompts the user again. So this is what happens here. So what we would say best practices when dealing with exception handling is we need to be specific to catch specific exceptions. For example, the zero division error, a value error, instead of using a bay exception, bay except, right? That one will cause the swallowing of exceptions. Right, so we need to avoid swallowing exceptions. We need to ensure you log or handle errors appropriately so you don't lose the valuable debugging information. We should also use the final for cleanup. Always release resources, files, network connectors in the final block. Right, so that is some good coding practice. Also, we need to keep the try block short. Place only the code that might raise an exception inside the try block to avoid catching unintended errors. So we should not clutter our code in the try block. We should only put the risk operation code inside the try block. So exception handling is an essential part of writing some robust Python applications. By using the try except and else, finally you can ensure that your code handles error gracefully and maintains a smoother user experience rather than a code which just throws up errors anytime. Right, so In the next session, we'll dive into Python file handling to learn how to work with files safely and efficiently. So feel free to experiment with these examples and share your questions or insights in the comment section. Don't forget to like, share, and subscribe, and follow for more.